As the industry increasingly embraces automation and robotics, understanding and adhering to safety standards is more important than ever. A3 has worked on updates to its ISO 10218 standard for nearly 8 years, implementing extensive revisions to address the latest safety challenges and technological advancements to the safety requirements for industrial robots, that would be the manufacturers, and safety requirements for industrial robot applications and robot cells. That's for system integrators. This standard not only clarifies functional safety requirements, but also introduces new considerations for cybersecurity and cobots, making it essential knowledge for engineers in the machine design space. Joining us today with her insights on how these changes will impact engineers in their designs, as well as the future landscape of safety in robotics, is Carole Franklin, A3's Director of Standards and Development. Thank you so much for being here, Carole.
Well, thanks for having me. I really appreciate the opportunity to tell your viewers a little bit more about our safety standards and what's in this latest update. So just to take a step back a moment, I'm the Director of Standards Development for Robots at A3, and we also have standards efforts in the machine vision side as well. But what I'm mostly involved in is safety standards. That's really long been A3's focus in the robot standards area. And we really believe that the safety of humans around robotics is a ticket of entry for the success of our industry. If people don't feel safe working around robots, that will cause problems for our industry. So, for over 40 years, A3 has been working with our committees of experts to develop guidelines or standards or basically requirements for best practices for keeping people safe around industrial robots. And I want to also mention that we have a role as a ANSI accredited standards developing organization. We have a role in organizing these committees, but honestly, it is the contributions of our committee members that truly makes standards work. So we have committee members, and I think the committee that worked on this particular document that we're going to be talking about today is what's called ISO Technical Committee, or TC 299, Working Group 3 for Industrial Robot Safety. So ISO TC 299 is for robotics, and Working Group 3 is for industrial safety of robotics. And so this group has had just tremendous participation from numerous countries around the world. I think TC 299 as a whole has something like 27 voting members, and I think most of them provided experts to Working Group 3. Certainly, more than 15 countries, probably closer to 20 or more, participated in this. And so the beauty for our industry is that as you have large multinational corporations that are developing robots, integrating robots, and using robots, when you have an international standard like the 10218 about safety requirements for those robots, now that minimizes the amount of re-engineering that you have to do to move from one market to another around the world. And actually, the previous edition of 10218, which was published in 2011, was really a huge success story about this. I think it was nationally adopted in, 15 or thereabouts countries around the world, and otherwise referenced in number of other countries as well. And what this means is that all of the national standards that are based on 10218 are essentially consistent with each other. So, when you have a 10218 compliant robot system in the US, it is largely also going to meet the safety requirements stated in Canada, which has also nationally adopted 10218. And likewise in Germany and Japan and Korea. And so, any large multinational company can see the value of having internationally consistent rules about how to keep people safe around these machines. And so, so that's what we've been doing. It's kind of our flagship standard. And in the United States, which is where we're located, as I say, we've been working on this area for 40 plus years. And in the United States, our equivalent safety standard is called R1506. And R1506 in the US is an ANSI document, an ANSI standard, and it is currently the U.S. national adoption of the previous edition of 10.2.18. So, and like I said, the Canadians have done the same. Our Canadian friends have nationally adopted the earlier version of 10.2.18 as their Z434, and so on. And so, so basically, the earlier version of the 10.2.18 is from 2011, was nationally adopted in the years that followed as the national adoptions in the case of the US R1506. The most recent previous edition was published in 2011 for the ISO 10218. And as you said, part one is about the safety requirements for industrial robots and is of greatest interest to the manufacturers of those robots. Part two is stating safety requirements for industrial robot applications and cells. And again, that is largely going to be of greatest interest to system integrators. But that's not to say that both the robot manufacturers and the robot integrators don't need to know what's in the other part. So I would highly recommend that people, regulators, insurance companies, users of robots, as well as manufacturers and integrators of robot systems, take up both parts, take part one and part two, and become familiar with how they work together, because they do work together. That's actually why in the US we've nationally adopted them together as a single document. So the 2011 10.2.18 part one and part two were nationally adopted as the 2012 R1506 together in one document. Because those of us who were working on the standard really felt it was important for people who wanted to use part one to also have access to part two and and be familiar with what's in the other part. And that's also true today. I mean, that's why the working group 3 in TC 299 worked on parts 1 and 2 together, so that the committees could look at both parts side by side and make sure that they made sense together. And so we are so excited. We are so excited to announce that the new 10.2.18 has been published. So the 2025 edition was published January 31st, 2025. And that marks the first time this document has been updated since 2011. And I tend to call them the 10.2.18, where I'm thinking of it as a single thing. And that's really what you call the series, the 10.2.18 series. And there has a part one and a part two. But because they are developed so closely integrated with each other, and in my mind, they're really a single thing. So I tend to refer to them as the 10.2.18. But of course, they really are two documents that are part of a series or family. If you think about what's been happening in the past 14 years over the development of robotics and the industrial Internet of Things and the ever increasing connectivity of things, you realize that really this is a very big deal. The update of this document is really a big deal, and industry has been waiting for it and very anxiously awaiting. So we've updated those, and what we've done is we've generally updated the technology that's being involved from 2011 levels to 2025 levels, and we've done some specific things to this document. Number one, we have updated how we treat safety functions. So again, if you think back to 2011, the last time this was published, there were fewer safety functions. They were kind of a newer thing. People weren't as familiar with them. And now what we wanted to do with this update was increase the clarity of how we handled safety functions in the 10.2.18 series. And so actually now we have put in a great deal more of guidance about safety functions. We've expanded the number of safety functions that we talk about from, I think it was 7 in the 2011 edition, to over 30 safety functions that are talked about. We have a whole annex in part 2 that's about when these safety functions are required, optional, or conditional. So conditional means if a certain condition is met, then it's required. But if that condition doesn't apply, then it doesn't apply. So it's conditional requirement. It's not totally optional. But anyway, so those required, optional, or conditional. That's described for these 30 some odd safety functions in an annex. And so we feel like we've added a tremendous amount of value to how safety functions are handled in this family of standards. So that's number one, safety functions. Number two is that we have integrated the concept of collaborative robot safety throughout the whole document or two documents. Basically, and in fact, we don't use the word collaborative robot. Um, it's kind of funny, but the safety standard world, it very strongly believes that there's no such thing as a collaborative robot. What there are is power and force limited robots or PFL robots, and those are the things that a lot of other people think of as collaborative robots. But in fact, it is possible to have a collaborative application using a non-PFL robot. Collaboration is involving allowing a human being to approach the robot's working space while it's in operation. And this can be done safely using a non-PFL robot. And so it's really, we consider that the application, the industrial robot application, is what can appropriately be said to be collaborative or not collaborative. And you can use a number of different types of robots to achieve that. Basically, the concept of collaborative robotics and the safety requirements of collaborative robotics is now been integrated throughout the whole document. So again, in 2011 edition, we basically said it's permitted, but we didn't go into details of how to do it. Then we published a technical specification or TS 15066 in 2016, in which we put forth more of the details about how to achieve it. And so now we've incorporated that those concepts throughout the whole document. And so now you get the one document, 10 to 18, largely part two, but a little bit in part one. And you don't have to go out and get the separate TS in order to get how to do collaboration safely. So, that's another thing. So we safety functions, collaborative robot applications, and safety requirements for safe collaboration incorporated into the main document and no longer as a separate thing. We've also incorporated some safety requirements that we had stated in technical reports or TRs on manual load and unload stations and also safety design for end effectors. So those things, again, like the TS 15066, those concepts had been treated in separate documents and now they're part of the main standard. And so and we also did take a closer look at cybersecurity. So those are the main differences in addition to just generally updating and clarifying.
It sounds like you guys really took everything that both the systems integrators and the manufacturers would need and just put it all in one spot. But where can they find that? Where can they find the document?
Yeah, well, we actually you can purchase the ISO editions, the 10 to 18 parts one and two, from in the US from the ANSI web store and also from the A3 web store. So and they they might be available in other uh, channels as well, such as if you have a subscription system, through Accurus, for example, most likely they have it.